Hello and welcome to this lecture, which is a continuation of the lecture on inverting a matrix by Gauss elimination method. What we do in this elimination method is that I have a matrix A and I convert all the diagonal elements of this matrix into identity matrix and set all the off diagonal elements into 0 by multiplying the given matrix by 3 elementary operations. So, what are these 3 elementary operations? The first operation is multiplying the ith row of a given matrix by a constant C. How do I multiply given matrix and get its ith row multiplied by C? I take this identity matrix, in that identity matrix I multiply the ith row by C. So, that is very easy to do, just convert the diagonal element in the ith row by C and multiply the original matrix. What is the next one? Exchanging rows I and k. Exchanging rows I and k is I take the identity matrix and exchange its ith and kth rows. That is very easy to do. Ith row had diagonal, ith row was diagonal was 1 here, in kth row the kth diagonal was 1. When you exchange in this new matrix, the 2 diagonals in I and k will not be 1 because you have exchanged them. So, that is my EIK, exchange rows of the identity matrix ith row and kth row. What is EIKC? Ith row, replace the ith row by C, replace the ith row by C times the kth row. So, examples are given in the next slide. See, this is EIC. What is EIC? The cth, the ith row and ith column is such that 1 is multiplied by C. So, this is C times the ith row. This is my EIC. So, what is EIK? EIK would be ith row and kth row exchanged. Suppose kth row was this particular row 1, 2, 3, 4, 5, 6. If 6th row is the kth row and 4th row is the ith row, when I exchange them, the 4th row, the new 4th row, there will be k in the 6th row and there will be 1 in the 6th row here and 1 in the 6th row, there will be 1 in the 4th column and in the 4th row there will be 1 in the 6th column, because I have exchanged the 4th row and the 6th row. That is my exchange value. And the third one is EIK of C. So, this is E13 of C. What is that? My first row is replaced by original first row. What was my original first row? 1, 0, 0. I have replaced it by original row plus C times the third row, C times the third row. What is C times the third row? 0, 0, C. So, when I add 0, 0 C to 1, 0, 0, I get 1, 0 C. So, this is that E13 of C. So, what is the effect of E13 of C multiplied onto the original matrix? What I get, the new result is the original row plus C times the third row. So, if I add original row plus C times the third row, I multiply on the left by E13 of C. So, this is my method. So, before I give a numerical example, I will give this algorithm, which is called the Gauss elimination algorithm. What are we doing in the Gauss elimination algorithm? The kth element, okay, the kth row is multiplied by AKK. So, what are these superscripts k and k minus 1? These are the stages. So, if I want to go from k minus first stage to the kth stage, I take the old matrix in the k minus first stage. In our case, let us say if k equal to 1, this is just the original AKJ divided by AKK. So, I am taking the kth row and dividing the kth row by the diagonal element of the kth row. So, what will it do? It will convert the diagonal element into 1, and whatever I do to my matrix A, the same thing I do to matrix B. What was matrix B? It was an identity matrix to begin with. So, in the kth stage, I take the k minus first stage BKJ and divided by AKK k minus 1. So, whatever I am doing to matrix A, I shall also do to matrix B. So, I will get the kth stage of matrix B from the k minus first stage. This is for my kth row. Then what do I do to rows other than k? Suppose now I want I not equal to k. For the remaining rows, so I take, now I want the value for the remaining rows. What do? That I take the old row, this is my old row, k minus 1 is the old, I want the new value now, old row minus aik of the old row multiplied by akj of the new row. So, the new matrix is akj of k, this is my new matrix or the new row. So, the new row multiplied by aik minus 1 of the previous version, previous stage, then when I do that, it will convert all the non-diagonal elements into 0. So, this we will show by an example. So, when I do this, all the non-diagonal elements will go to 0 and whatever I do to matrix A, I shall do exactly to matrix B. So, this I shall do for all the other J's. So, now how many stages will be there? Okay. There will be n stages now. Okay. After the n stages, the matrix A in the n stage will become identity matrix and the matrix B will become the A inverse. Okay. So, what is the initial condition? Initially A0 is equal to A and B0 is equal to I. So, I do n stages. What is this n? This is equal to number of rows or columns. Okay. After this n stages, I will get the original matrix become the identity matrix and the original identity matrix becomes the A inverse. So, this is my Gauss algorithm. It is also called Gauss-Jordan elimination method. So, now I will take a numerical example. So, my numerical example, I had illustrated this little bit in the last lecture. So, my matrix is 4, 8, 2, 1. This is my first row, 1, 5, 3, 8 second row, 2, 7, 1, 4 third row and 3, 8, 2, 1 is my fourth row. And what is my matrix B? B is the identity matrix 1, 1, 1, 1, the rest are all 0. So, what is my strategy now? The first row, I had this first row, I will convert the first value 4 to 1 and the remaining these 3 values I will convert them to zeros. How will I convert this 4 into 1? By dividing the entire row by 4. So, that is my first operation, divide the first row by 4. So, how will I do that? I will use that identity matrix and the first row and first column of identity matrix will be 1 by 4, because when I multiply by 1 by 4 into 4, I will get 1. Okay. So, that is my first operation. What will I do in the second case? So, in my new first row will be 1, 2, 1 by 2, 1 by 4, because I have divided this by 4. So, new value of this is 1 now. So, if I subtract the new first row from the second row, if I just subtract, I will get 0 here. So, that is what I am doing here, subtract the new first row from the second row. What was the new first row? 1, 2, 1 by 2, 1 by 4. So, I subtract from the first row, this will become 0. Now, subtract 2 times the new first row from the third row, because third row this element is 2. So, only when I subtract 2 from this 2, I will get 0. So, my new row was 1. So, I subtract 2 times the new first row from the third row. So, what do I do for the third row now? I subtract 3 times the first row, new first row from here. So, 3 minus 3 will be 0. So, that is what I do. So, what are my operations now? If I want to subtract 2 times the first row from the third row, it is E31 minus 2, because minus 2 means I am minus 2 times the first row. I am adding to the third row. So, what is the last one? So, minus 3 times the first row, minus 3 times the first row is added to the fourth row. So, that is E41 minus 3. So, when I do these operations, you will see the result in the next slide, but exactly the same things I will do on the matrix B, which was I to begin with. So, let us see the next slide. Okay. So, what was this numerical example? First stage 1, divide the first row by 4. Look at this. I am repeating what I said earlier, because it is only when you do an algorithm by hand, you will understand the algorithm very clearly, because only when the computer does everything for you, you do not see all the operations, and if the operations are not correct, you will get an incorrect result, and it takes quite a bit to understand what went wrong in your computer program. So, if you know a numerical method and apply the computer program for this numerical method, every step will be clear. So, the first row has become 1, 2, half, 1 by 4. What have I done in the next stage? I have subtracted this new first row from the second row. What do I get? 1 minus 1 is 0, 5 minus 2 will be 3, then 3 minus half because I am subtracting from the old second row, I am subtracting the new first row. So, 3 minus half will be 5 and a half, 8 minus 1/4 will be 31 by 4. So, from the second row I have subtracted the new first row. What will I do for the third row? I subtract 2 times the first row. So, 2 minus 2 times 1 is 0, 7 minus 2 times half. I have 7 here, I need to subtract 2 times half. So, that is 1. So, actually this is not correct, this should have been 6. Okay. Now, what is the fourth row? This is the last element. I multiply 2 times this. What is 2 times 1 by 4? 2 times 1 by 4 is half. So, I am subtracting half from 4, I will get 7 by 2. So, this 0 is incorrect. So, correct it appropriately. How do I correct it? 7 minus 2 into this, that is 1. So, this should be 6. So, correct this 0 into 6, and what is my last row now? 3 minus 3 times 1, that is 0. Then 8 minus 3 times 2. 3 times 2 is 6. So, 8 minus 2 is 2. So, I have 2 here. Then 2 minus 3 times half. 3 times half is 3 by 2. When I subtract 3 by 2 from 2, I will get half. And what is my last particular element? 1 minus 3 times 1/4. 3 times 1/4 is 3 by 4. When I subtract 3 by 4 from 1, I will get 1 by 4. So, this is my new A. What is the A obtained after the first stage? In the first stage, I have made the diagonal value of the first row into 1 and all the off diagonal elements to 0. So, my first stage will be these 4 operations. These 4 operations are 4 elementary matrices. I did all these 4 operations by multiplying A by 4 elementary operations on the left side. So, that is my end of stage 1. So, similarly for stage 1 of B. So, B1 will be exactly the same operations that I did on A, I will do on B. So, as a result what will happen? The first one will be 1 by 4 because I have divided the first time by 4, that is 1 by 4, and all the remaining I have obtained from whatever operations I did on matrix A. So, this is my matrix B. So, you see that as the first row, first column of my original matrix is replaced by 1 0 0 0, the first column of my matrix B is replaced by other objects. All the other elements of B are unchanged. So, what will be my strategy for the second matrix now? For the second stage? So, I shall start with the diagonal element of this. So, I shall divide the second row by 3. So, which is the second row now? Second row on a matrix of the last value obtained in the stage 1. A1 is the last result of stage 1. So, I will make this 3 into 1. So, that is my next slide. Let us look at this. So, what do I do? This is my A1 and this is my B1, exactly the same result that I had from the earlier slide. So, what will I do? Divide the second row by 3. So, how do I do that? Take the identity matrix E and the second row of this identity matrix is replaced by 1 by 3 instead of 1. Okay? Okay? So, I am going to divide the second row by 3. So, I will take this E2 1 by 3. So, E2 1 by 3 is the identity matrix where the second row is replaced by 1 by 3. So, what will I get? 0 by 3 is 0, 3 by 3 is 1, 5 by 2 divided by 3 will be 5 by 6 and 31 by 4 divided by 3 will be 31 by 12. Okay. See, this is what has happened in A2. So, the second row of A2 now, second row of A2 is the original row divided by 3, that is my operation. So, my second row is 0, 1, 5 by 6, 31 by 2. So, similarly the second row of B2 also will change. Let us not worry about B2 right now. So, once I have this as my second row, what do I have to do now? Now, I have to make sure that the second row of A1, entire second column of A1, the diagonal element has already become 1. Now, the off diagonal elements I want to make it 0. So, how do I make the off diagonal element 0? So, this is my second row here. So, to make the off diagonal element 0, I subtract 2 times the second row from the first row here. What will happen? 2 times 1 will be 2. So, when I subtract 2 from 2, I get 0. So, I want to make the entire second column other than the diagonal element to be 0. So, to convert this 2 into 0, I take the row of after the first stage in the second one, I take this row, multiply by 2 times this, and I subtract from the first row. So, that is my statement here, subtract 2 times the new second row, this is my new second row, subtract 2 times this from my first row here. When I subtract that, what I will get is 1, 0, minus 7 by 6, minus 59 by 12. So, let us see how I got this minus 7 by 6. What did I do? 2 times 5 by 6, 2 times 5 by 6 will be 10 by 6. I subtract 10 by 6 from 1 by 2. What is 1 by 2? 1 by 2 is nothing but 3 by 6. When I subtract 10 by 6 from 3 by 6, I will get minus 7 by 6. Similarly, I have 31 by 12 here. Now, I take 2 times 31 by 12, that is 31 by 6. Okay. When I subtract 31 by 6 from 1 by 4, I will get minus 59 by 12. Do that operation to convince yourself that the new first row in the second stage, new first row will be 59 by 12. Similarly, what do we do? I have 3 in the third row here. So, I want to set this 3 to 0. So, how do I do that? This is my old second row, multiply this by 3. So, when I subtract 3 times the second row from the third row, okay, that is what is written here, E32 minus 3, that is take 3 times the third row and subtract from the second row. So, this is what it is. So, this 3 becomes 0 and I have to subtract 3 times 5 by 6. What is 3 times 5 by 6? That is 5 by 2. So, I have to subtract 5 by 2 from this 0. Okay, this is my, so when I subtract 3 times 5 by 2 from this 0, I should get, check this. So, let us see the last one. I have 31 by 12, 3 times 31 by 12 is 31 by 4. So, I am subtracting 31 by 4 from 7 by 2, 7 by 2 is the same as 14 by 4. So, 14 minus 31 is 71, so, sorry 17, okay, I get 17 by 4. Similarly, I take 2 times this particular row and subtract it from the last row of A1. So, when I do that, I will get 0, 0, minus 7 by 6 and minus 15 by 2. So, this is my matrix that results from at the end of stage 2. What does stage 2 involve? 4 steps. Dividing the first row by 3, subtracting 2 times the new second row from the first row. So, all these 4 operations are all the operations on stage 2. So, how did I execute? I multiplied my original matrix A by these 4 matrices on the left side. So, first stage also we have 4 steps, second stage also we had 4 steps. So, at the result of my second stage, my A2 has become this matrix and B2 has become this. So, what are the main observations here? You will see that the diagonal element of A2 has become 1, second stage end, and all the off diagonals have become 0. And on my matrix B, both the first and second columns have changed and the third and fourth have not changed at all. So, now I have to go to the next stage. What is the next stage? I start A2 which is the end of stage 2, B2 which is the end of stage 2. Now, I want to operate on the particular third column now. What is my third column? Third column, third row, this is minus 15 by 6. So, how do I convert this minus 15 by 6 into 1? I have to multiply by minus 6 by 15. So, this is stage 3. The third row of my matrix is multiplied by minus 6 by 5. What is the result? This diagonal elements become 1 and the last element I multiply 17 by 4 by 6 by 15. So, what I will get is minus 17 by 10. So, how do I get minus 17 by 10? I have taken minus 17 by 4 multiply by minus 6 by 15. So, I shall get 17 by 10. So, that is the third row, which is the first stage of this, which is the first step in the third stage. So, what do I do? Once I convert this diagonal element into 1, now I have to convert all the off diagonal element into 0. So, how do I do that? So, now I have so this has become 1. So, I want to convert this 7 by 6 into 0. So, what do I do? E13 into 7 by 6. When I do E13 7 by 6, this element has become 0 and others have changed like this. Then what do I do for the second row? I want to convert this 5 by 6 into 0. So, what do? I take 5 by 6 of the third row with a minus sign, and so since this is 5 by 6, I multiply this by 6 by 5 with a minus sign. So, when I add, this becomes 0. So, what do I have to do for the last particular column here? I had minus 7 by 6. So, I multiply this by 7 by 6 and add. So, when I add that, minus 7 by 6 plus 7 by 6 gives me 0, and the last column has changed. So, what has happened after at the end of stage 3? So, I had A2, which is the end of stage 2, multiply E3 minus 6 by 15. This is the first one I operated. Second time I did E13 7 by 6, then E23 minus 6 by 5 and E43 7 by 6. I multiply by these 4 matrices on the left of A2 to get A superscript 3. So, this is the end of stage 3. End of stage 3 involves again 4 steps operating on the end of stage 2. So, this is my matrix at the end of stage 3. Similarly, B3 has changed in this particular manner. So, what is remaining now? Only the last particular stage. What is my last stage? I start with A3, which has minus 44 by 5, 44 by 15 in the last diagonal element. So, I have to convert this into 1 and I have to convert all the remaining to 0. So, that is my next stage. So, what do I do for the next stage? I took the E4 into minus 15 by 4, that converts the last diagonal element into 1. Okay. Then what is the next one? E14 into 40 by 15, E24 minus 7 by 6, E34 minus 17 by 10. I multiply this sequentially, on A3. So, I have shown here. How do I get B4 now? Same as what I do for A3. I take B3 and on the left of B3 multiply first by E4 of minus 15 by 44. This is my first one. Second one is E14 of 44 by 15, E14 by 44 by 15, E24 7 by 6 and E34 minus 17 by 10. So, when I do this is the final result for my B4 and this is my final result for A4. So, what has happened in this process? The end of stage 4, the matrix A became a diagonal matrix and the matrix B became this particular matrix. So, what is the meaning of that? How many operations I had on this original matrix? For each column I had 4 matrices. So, when I get the last result of A4, I have multiplied on the left of the original A by 16 elementary matrices, because in each stage I am multiplying the earlier stage by 4 elementary matrices. So, after multiplying by these 16 matrices on the left, my A became diagonal, and what happened to B? B became this matrix. So, B4 is nothing but A inverse. So, that is what will be on the next slide. Okay. You will see that. Okay. Let us see this again. When I multiplied by those 16 matrices on the left of A, I got this matrix, which means that if I multiply by the same 16 matrices on the identity matrix, what I get is my A inverse, because I know that A into A inverse is identity matrix. So, to get this identity matrix, I have to multiply on the left by A inverse. So, that is nothing but B4, B4 is nothing but A inverse. Then the other thing we wanted to do was to get the determinant. So, you will find that I had multiplied by several elementary matrices, and you can easily verify that the determinant of those elementary matrices is 1 except when you divide or multiply a given row. So, the determinant is given by original value A110, A221, A332, A443. What was A110? A110 was 1, okay. A110 was 4, okay. A221 was 3, A332 was minus 15 by 6, and A443 was minus 44 by 5. So, when you multiply all these things, you get the determinant of the matrix. So, what is the determinant of the matrix? Product of all the diagonal values of my elementary matrices. So, that is my determinant. Okay. So, now what we need to do? We now need to write a program to perform this elimination algorithm, which is the Gauss elimination algorithm. So, I shall briefly describe this program. I will start describing this program now. We will also execute this program in our practical session. So, let us just see the outline of this program, and then in the next class or so I shall consider the detailed program and execute it. So, how do we structure this program? The structure of this program would be, since I am dealing with matrices, I have to deal with array variables. So, I will define 3 array variables now, A, B and C. Okay. What is A now? A is a 2-dimensional array where each dimension goes up to 25. So, this is A 25 25 means it is a 25 by 25 matrix, B 25 by 25 means it is again 25 by 25 matrix, and A old is an additional matrix. I may need to store the information on A. Okay. So, this is my dimension statement I need to declare because I am having array variables. Whenever I have array variables, if I do not have a dimension statements, I cannot use that at all. So, then I need to read and write to files. For that purpose, I have said open unit equal to 11, file equal to input 1 dot dat, open unit equal to 12, file equal to output dot dat. Okay. And now I read n. What is n now? The particular size of my matrix. If it is 4 by 4, my n will be 4. Okay. So, once I read this n, this I am reading from the screen now, I am reading from the screen. Now, epsilon is some variable which I shall use, because many times there is no such thing as a actual 0. So, we want to take in place of 0, you want to take something like 10 minus 8. Okay. So, then I shall read the entire matrix A. How am I reading now? Read 11 comma star Aij, j going from 1 to n, I going from 1 to n. What is this kind of a read statement? This is a read statement, is an implicit read statement. Okay. So, j going from 1 to n is a do loop which takes j from 1 to n, and I going from 1 to n is a do loop which takes I from 1 to n. So, if n is 4, I will read 64 values of matrix A from this read statement. Where is it reading from? Reading from 11, and that 11 is nothing but input dot dat. Okay. So, remember that my j changes first and I changes later. So, which means I am reading the matrix row wise. First row I read first, A11, A12, A2n, okay. Then second row, third row, fourth row. So, it is very important when you deal with matrices to keep track of whether you are doing the row operation or column operations, because both I and j are loop variables, often it is confusing. So, it is good to keep track of whether you are doing a row operation or a column operation. What I shall do now, I shall conclude this lecture. I have just started the program for matrix inversion. So, in the next class, I shall do a little more on matrices and then go ahead with the program for matrix inversion. I shall close here. Revise this lecture carefully, because you need to know all the steps in Gauss elimination method to get an inverse of this matrix. So, I shall conclude here. Thank you very much.